Okay, so those who are from non-chemical engineering background, hopefully be beneficial for you guys. I want to touch a bit on main equipments. Where is the chat? Okay. So, so we start with pumps and then compressor. These are the list of type of pumps and compressor that we have in the refinery. We start with centrifugal pumps and compressor. Why we need centrifugal pumps? I mean, if the unit require a lot of gases, I mean flow rate, the designer will use centrifugal pumps. But then if it require more pressure, discharge pressure outgoing from the compressor, it will choose reciprocating pump. iPhone 7 have question. It's not. Okay. Okay, later. Centrifugal pump, diaphragm pumps, and midstream pumps. So diaphragm pumps, typically it's a smaller pump used to inject chemicals. So there's a lot of chemicals used in the refinery. We have what you call it? Anti-corrosion. Yeah, it's more like anti-corrosion chemicals that will be injected to the refinery. So normally we'll use diaphragm pump, or some of it maybe midstream pump. So these are on the smaller side, and this is on the bigger side. I mean bigger pumps. The conversion to olefins occur in refinery. Or okay, for me, the conversion into olefins occurs in steam cracker. So steam cracker, like I said, is a bridge between refinery and petrochemicals. In normal setup, normally steam cracker may be part of refinery. Okay. So we have one question from iPhone 7. Difference between boiler and furnaces. Boiler, okay, furnace. This is furnace. iPhone 7. This is furnace. Okay, just imagine there is a boiler upstairs. Just imagine this is boiler for the sake of this study. This is furnace and this is boiler. Boiler, okay, if this is boiler, meaning this is waste heat boiler. But the boiler that I mentioned in the cogeneration plant is basically a main burner, a very big burner that will be used to fire up the natural gas. And then it will pass through the series, or no, it will pass through an heat exchanger. So this heat exchanger in the shell side is basically water. So when this flue gas, hot flue gas, passing through this heat exchanger full with water, this water will evaporate and creating steams. So this is what boiler is. But for this example, if you have boiler up here, we have this is what we call waste heat boiler. So waste heat boiler basically is the fuel gas generate from this bottom part. Will be heat up this waste heat boiler, and the water in this boiler will evaporate and then producing steam. So this is waste heat boiler. So please don't get confused. So we have waste heat boiler, we have a boiler. So boiler typically will be a lot bigger, especially in cogen plant. It can be as big as 2-story houses. Yeah, I mean it's very big. Okay, so I hope I answer your question. Yeah, was it iPhone 7? Yeah. Mr. Hong, May I know salary is higher to work in a refinery or petrochemical plant? Depends. Hmm. Uh, depends. Yeah. Petrochemical plant. I'm not sure about petrochemicals. It depends. It depends, Song. To be frank, I don't have basis or for petrochemicals. But I do have a friend of mine who are working in BASF, BASF Petronas in Gebang. But from what I can tell, maybe the salary is slightly on the lower side. That's all I can tell. But then it will still depend on the company itself. So I just can give you a rough figure. That's all. To get more details, I think maybe you can visit Glassdoor. Try to search for the salary lah. All right. All right. So we have 20 more minutes, I think. Oh, Rizal. Okay, we have question from Rizal. What happens if the plant is under fire or leak gas detected? Okay, okay. Uh, and also what happened to the plant if any of the unit operation detecting high pressure or high temperature deviation from normal set point? If the blowdown happen upon fire, does all the blowdown gas will route to the same flare system? Yes. Rizal, betul. It's true. For flare system, it's designed for global. What we call it? There's a term, specific term. Global. It's a global scenario. Yeah, I think that's the right term. Global scenario, meaning to say, uh, if the plant is tripped, right, due to power failure, for instance, definitely the whole plant will trip, and there will be a lot of relief valve being operated, and all these gases will be routed to flare. And it is important for the flare to be designed to cater for global scenario. Yeah, of course, you have to run. Well, not necessarily. iPhone 7. I mean, a good refinery will have a very good safety precautions, right? So, like I said, I mean, for flare, it's definitely need to design to cater for the global scenario. So all the blowdown gas, all the gases that been going out from the unit need to be routed to the flare, right? Okay, for flare, for fire heater, there are lists of type of fire heater. We have fuel gas fired, we have gas fired, we have forced draft, induced draft, balanced draft, side fired, bottom fired. Any idea what is this term for? Perhaps if I can get some input from the audience. So fuel fired, gas fired, uh, fuel fired, gas fired. Gas fired, basically, we're talking about hydrogen gas fired. Of course, the operating cost will be a lot higher compared to fuel gas. Fuel gas can be natural gas mixing with more heavier gases or hydrocarbon. So yeah, there's a bit different. I mean, the difference is only on the burner design and also on the flue gas generated. So yeah, I think that should be covered in the design part. I won't get into details on this. For forced draft, we will have a blower. We call it a blower. Gas like natural gas, yes. Gas like natural gas, yes, it is. Yeah. So for forced draft, we will have a blower. A blower will act as a combustion air. So you will force the combustion air to the burner. That's what we call forced draft. For induced draft, we also have a blower. So this blower will be located at the flue gas side. So remember, we have combustion air. Combustion air react with fuel, then it will have a fire, and then it will generate flue. So combustion air is at the upstream side. Flue gas is at the downstream side. So for induced draft, this blower will be installed at the downstream side, which is at the flue gas side. So basically, it will suck all the flue gas out from the fire heater. And then we have balanced draft. Balanced draft, as the name implies, we will have both blower at the combustion air side and also at the flue gas side. So the control of this fire heater will be a lot more better compared to forced and induced draft. So we have side fire and bottom fire as well. So side fire is uh, side fire is basically talking about the burner side. The burner is from the side. If it's bottom fire, meaning the burner is from the bottom side. So that's all. Okay. Distillation column, we have 15 more minutes. Distillation column, so these are the column tower that you can, observe in the refinery. You can see a very big wide column. You can see a thin column but taller. So of course the design of the column will be subject to the separation requirement. So I think it will be varies from one unit to another. So for column, this is internal. We have sieve tray, bubble cap tray, chimney tray, or pack bed. For a high efficiency separations, typically they will select bubble cap tray, because for bubble cap, it can provide a very good contact between gases and the liquid. And that's why the efficiency of the separation will be a lot higher compared to sieve tray. What is sieve tray? Sieve tray, if you can see in the picture on the right hand side, you can see there's a hole. So just imagine there's no tray, it's a hole. So that is what we call sieve tray. So the contact between gases and the liquid is not as good in the bubble cap tray. And we have chimney tray and then pack bed. Pack bed normally used in the crude distillation column. Also, the main objective is to improve the separation efficiencies. Okay, heat exchanger. This is very typical in refinery operations. What we have here, this is a shell and tube heat exchanger. And then together we have on the right hand side a picture of a tube bundle. So this is tube bundle of the heat exchanger. This is basically inside of the of this heat exchanger. Yeah. So there are three types as far as I know: shell and tube, welded plate, and spiral. Hmm. Divided wall distillation. Wow. Divided wall. Sorry, iPhone. I don't have such info. Perhaps on later, in later punya session. Divided wall. Oh, iPhone. Can you just can you elaborate? Divided wall. We're talking about wear loading. Okay. All right. May I know the advantage of using spiral heat? Oh, okay, Mr. Hong. Good question. Okay. Why we need heat exchanger in the first place? Yeah, I was looking for this question. Of course, heat exchanger is used to recover the heat. And these are the main purpose of heat exchanger, right? To recover the heat. This is the only objective of having heat exchanger in the plant. So we have shell and tube, welded plate, spiral. So going so shell and tube, these are the typical design. Welded plate, just imagine plate with a very small hole in between in contact together. The main purpose is to create more surface area, which is contact between the hot stream and the cold stream, so we can recover heat as much as possible. For spiral, I think it's a new design. Spiral, I don't have a proper picture to show. So basically, just imagine shell and tube, but the orientation or the layout of the tube is spiral type. Also, the intention of spiral is also to maximize the contact, the surface area contact between hot stream and cold stream. Is it the process need heat that loss? Yeah. So basically the heat that the unwanted heat, right? Oh yeah, maybe I forgot to mention this. Some of the reactor will will uh, will create heat. And for those from a chemical engineering background, we have endothermic and exothermic, right? Endothermic will consume heat. Exothermic will create heat, will produce heat. So this extra heat is not required. So how do we channel it? Using heat exchanger. So the extra heat, the unwanted heat, can be used to heat up the feed incoming, the incoming feed. So by preheat the feed, we can reduce the amount of fuel gas consumed to the unit. All right.